What is the electronic configuration of zirconium? What is the electronic configuration of zirconium? So this is zirconium, right? This is zirconium. This is the symbol. This is uh, the mass number, which is 91, and this is the atomic number. So in a neutral atom, the atomic number is equal to the number of proton and it is equal to the number of electron, right? So zirconium has what? 40 electrons. So these are the number of electrons that we will be configuring. So how do we configure these 40 electrons? So we can configure these using the Hofbauer principle. So the Hofbauer principle states that electrons fill orbitals in order of increasing energy level. So the order of increasing energy level goes like this. So we have one s, we have 1s, we have 2s, we have 3s, we have 4s, we have 5x, we have 6s, we have 7x, right? Then we go to the next orbital, which is the p orbital, right? And it starts from the second energy level. So we have 2p, we have 3p, we have 4p, we have 5p, we have 6p, and we have 7p. Then the next orbital is the d orbital, and it starts from the third energy level. So we have 3d, we have 4d, we have 5d, we have 6d, and then we have 7d. And then we move to the last one, which is the f orbital, and it starts from the fourth energy level. So we have 4f, we have 5f, we have 6f, and we have what? 7f. So the order of increasing energy level goes like this. So we'll fill the 1s orbital first before going to the 2s orbital. From the 2s orbital, we'll go to the 2p orbital and then to the 3s orbital. From here, we move down to the 3p orbital to the 4s orbital. From here, we move to the 3d orbital, 4p orbital, and the 5s orbital. From this, we move to 4d orbital, 5p orbital, and the 6x orbital. From here, we move down to what? The 4f orbital, the 5d orbital, 6p orbital, and the 7s orbital. So this is the order of increasing energy level, right? So, and you must remember that the s orbital will take a maximum of what? 2 electrons. The p orbital will take a maximum of 6 electrons. The d orbital will take a maximum of 10 electrons, and the f orbital will take a maximum of 14 electrons. So putting this into consideration, we have 40 electrons. So these are the 40 electrons we'll be configuring. So I will start with the first energy level, which is the 1s orbital. So I will have 1s2, right? Because the s orbital will take a maximum of 2 electrons. Then I move to the 2s orbital. So 2s2, right? Then I move from here, I move to the 2p orbital, then to the 3s orbital. So p will take a maximum of 6 electrons. So that will be 2p6, and then to the 3s2, right? So from here, I move to the 3p orbital, and p orbital takes a maximum of 6 electrons. So that will be 3p6. From there, I move to the 4s2, right? From here, I will move to the 3d orbital, and d orbital will take a maximum of 10 electrons. So this will be 3d10, right? From the d orbital, I move to the 4p orbital. So that will be 4p6, right? From the p orbital, from the 4p orbital, I move to the 5s orbital. So 5s2, because s orbital will take a maximum of 2 electrons. From here, I will move down to the 4d orbital, right? 4d orbital, and d orbital will take a maximum of 10 electrons. So 4d10, right? So let's calculate if all this is up to what? 40. 2 plus 2 is 4. 4 plus 6 is 10. 10 plus 2 is 12. 12 plus 6 is 18. 18 plus 2 is 20. 20 plus 10 is 30. 30 plus 6 is 36. 36 plus 2 is 38. So I have 2 electrons remaining. Here is what? 38 electrons already, right? So remaining 2 to make it 40. So this would not be, this would no longer be 4d10, but because we have only 2 electrons remaining, so we fill those 2 electrons into that part. So that will give us what? 4d2. 4d2. So if I calculate all this, it is equal to 40. Again, 2 plus 2 is 4. 4 plus 6 is 10. 10 plus 2 is 12. 12 plus 6 is 18. 18 plus 2 is 20. 20 plus 10 is 30. 30 plus 6 is 36. 36 plus 2 is 38. 38 plus 2 is what? 40. So this is the electronic configuration of zirconium that is having 40 electrons, right? So if we take any of these number, we have 1s2, right? So these two represents the electron, right? It represents the electron, the number of electron. This S represents the energy sublevel, which is also referred to as the orbital, right? So this is the orbital, or what? Energy sublevel, right? And this one here represents the energy level. So these are the 3 things in electronic configuration. We have the number of electrons, the orbital, which is also known as the energy sublevel, and we have the energy level. So 1 is the energy level, S is the energy sublevel, which is also known as the orbital, while this 2 on top is the electron, is the number of electrons. We can also take 2p6. 2 is the energy level, P is the orbital or the sub-energy level, and 6 is the number of electrons. So to write electronic configuration, it's very important that you remember this chart. Learn how to write it at any time. So this is the off-board chart, right, for writing electronic configuration.